Hello again. Welcome to the third part. The videos are short, but hopefully you are keeping up. Before we go on, you should pause this video and read this question and try to understand it. As I go somewhat fast through it, you'll be able to keep up better. Okay, do that, and I'm just going to keep talking. Okay, hopefully you did that. Read the problem. This is a geometry problem, and you're trying to find a function rule for, the area of a triangle where the height is 4 more than twice the length of the base. Okay, now anytime you have a geometry question, you should create a visual representation. There's a triangle. That's a pretty good one for me as well. And it says the height is 4 more than twice the base. Okay, so let's use the letter B to represent the base. They do that down here because I know that's coming. And let's let this be the height. All right, so h is the height, and they tell us that the height is 4 more than twice the base. So if you take two of these bases and you stack them up and add 4, you'd have the height. So it's not perfectly to scale, but you get the idea, I hope. All right, now the thing is we don't know how long the base is. Okay, so the height depends on how long the base is. Did you hear that language? Height depends on base, right? From what they've told us here. So in this part right here, the height is equal to 2 times the base plus 4. And they talk you through it in this line right here. Okay, well, if we know that's our function. Okay, so it says write the function rule for that. Okay, well, that's the beginning of it. It's not completely, because the function rule is actually supposed to be the area. Okay, so that's the height, but the area is down here. Okay, we know that the area of a triangle is 1/2 times base times height. Hopefully you know that. Okay, well, the problem is that the height is this. Okay, the height is 2b plus 4 in this particular triangle. Okay, so if I know that the height is 2b plus 4, here's what you have to do. Now over here, I like this. I sometimes forget to talk about it, but they tell you why they do what they do over here. You have to substitute for h. Okay, this h, we have to substitute this 2b plus 4, because 2b plus 4 is the height, because it's twice the base plus 4. So here in parentheses, we're going to go 2b plus 4. Okay, that is the height. That's basically h. Okay, 1/2 times base times height, and the height happens to be 2b plus 4. Now, to simplify this, you have to distribute the 1/2 b, which is right here. Okay, so we have to distribute 1/2 times 1/2 b times 2b. Okay, so they break this down for you here. You have 1/2 times 2, and then you also have b times b, which is basically b squared. B times b is b squared. Okay, here's a note for you over there. B times b equals b squared. Okay, so that's where this little 2 came from here. Plus, now you have to go 1/2 b times 4. Well, there you have 1/2 times 4 times b. Okay, because you have to multiply 1/2 b times 4. 1/2 times 4b. And 1/2 times 4 is 2. And you still got the b. And then that's just b squared. The reason there's nothing here, 1/2 times 2, is 1. So you just write a equals b squared plus 2b. Okay, that's the function rule for the area of the triangle. So that's actually the answer to the first question. Okay, that's the function rule. Now, as I've said in the previous video, you could have written, instead of a equals, you could have written a as a function of the base is equal to, and then you would write the rest of it there. It's the same thing, as we've said over and over in these videos here. Okay, but there's another question they want you to answer, and that other question is, what is the base if the base is 16? So all we're going to do now is we're going to plug 16 in to the base. Okay, so you have 16 here, because they want to know if the base is 16, well, what is your area there? 16 squared plus 2 times 16. Okay, let's do the math. I've done that for you. I worked ahead a little bit. 256. 16 squared is 256 plus 32. and that adds up to be 288. So the area of that particular triangle is 288 inches squared. All right, so that's the second part of the answer to this question, that it said what is the length when the base is 16 from the original problem. All right, so from there they take us to this question that says graph the function rule and how do you know that it's nonlinear? And then they ask you to complete the values here. So to save you time, I'm just going to do a couple of them here. I'll do this one right here. Here's the function rule we just determined. All right. It was, let's see, a equals b squared plus 2b. It's from the same problem from up here. So I'll do 7 for you. So you would stick 7 squared in there plus 2 times 7, and then you'd work that out to get 63. Okay, now the other numbers, you need to double check me on this. The other values come out to be 3, 24, 63 we got, and then 120. I'll need you to pause the video and double check to see that you know how I got through those. Okay, and then what we're going to do now is we're actually going to graph those points. All right, so let's do that real quick. Going to the next page. Now I don't have them where you can see them, but you can see them on your page. The first one was, let's see, and I just forgot it. It was, we've got 1, 3, 424, 763, and 120. So if we plot those, it comes out to look something like this. In fact, I'm going to pause the video, graph it, to save you some video time. Would you please graph it on your own? Hit pause here and come back and see if we agree. And poof, like magic, there it is. Hopefully you did that first. I hope you did. And agree that it looks something like that. It's slightly curving, so it says, how do you know that the rule is nonlinear? Well, we know that because the graph is curved. Graph curves. Okay, a more mathematical way of saying that, and we get into this later, is that the rate of change, F, rate of change, is not constant. Now, one thing, as I created this graph, that you should have done if you did this on your own, hopefully, is wondered, should I or should I not graph or connect this graph based on the type of data we have here? Well, this axis here is the length of the square side. I'm sorry, of the triangle side. It's the length of the side. Okay, it's a triangle, not a square. Okay, and then you wonder, could the length of your sides be fractions or decimals? Could they be values in between whole numbers? Well, they could. You could have a length of a side that, or length of a base that is 2.5 or 2.51 or 2.52. So there is infinite number of possibilities in the independent variable. Okay, so we do connect it because of the context of that question. With that said, let's finish up by answering these last two questions. It says, is the graph of a function rule that relates a square's side to its side, is that continuous or discrete? And they ask you some leading questions here. A blank, either continuous or discrete graph is unbroken. Do you remember what that is? Continuous. It's not broken, it continues infinitely. A blank graph is composed of isolated points. In other words, meaning there are breaks. That would be discrete. The number of possible values for the length of a side is finite or infinite. Well, if we can have any possible value in between whole numbers, it would be infinite. So would that graph be continuous or discrete? It's continuous, just like the example we did up here that I'm just now talking about squares. It's continuous because B/C, because the length of a square can be any positive value including fraction values. Between whole numbers. Okay, so that wraps it up for today. So hopefully you got all that done and thought about it, and bring those to class, and we'll get rocking and rolling on that. See you soon.